Hi, I just wanted to do a quick demo of some tools that might be useful in an OER stats class, and I'm going to demo them using this website called Cocalc. It's just cocalc.com. This is actually freeware. You can run it on your own server, and in fact, Shweta is running some instances of this right now on machines that are local to John Jay. And the advantage of that is that it's completely free for students to use. If you use cocalc.com, then students have to pay something like $14 a semester. It's still very affordable for what you get. And it comes with a lot of great course management stuff that I like to, but which I won't talk about in this video. So I'll go to the project that I'm currently working in. By the way, all of this stuff is not specific to Cocalc. This Cocalc is basically just a cloud Linux virtual machine with an IDE, which you can interact with through HTML. So everything that we're talking about here, these files are worksheet files, and each of them is written in a different language in which you can do statistical operations. And everything that I'm going to do can be done on any Linux distribution. It's just that we're using Cocalc because it's a convenient way to solve the problem of students installing Linux, etc., etc., etc. It's also a great way to get around DoIt. So I will just start with what I think is the simplest one, which is Python. So in each case, I just did a little demonstration of something that might be interesting to do in a statistics class. And so, explaining Python is definitely beyond the scope of the video, but I think it's just kind of clear what's happening here. You make 100 random numbers, look at the first 8 of them, and then you use this package called Numpy to do statistics on that array of numbers. So you can get the mean, the variance, the standard deviation, and so because this is a pseudo-random number generator, this is a uniform distribution. So you can import the uniform distribution from scipy.stats and then scale it up to 100 so that it goes from 0 to 100 instead of from 0 to 1, and look at the mean, the variance, and the standard deviation. And wow, they're very close to the experimental values that we got from looking at the randomly generated data. It can also do plotting. So what is this from the Numpy libraries? You get a range of values. I think these are values between 0 and 5 with a separation of 0.2. And so you can plot a line, which is just it's just the values. Just the values printed with the corresponding index. Is that right? And so this is the red line, and then you can plot the square, and that makes the part of the figure here with blue squares, and then you can plot the cube, and that's with the green triangles, and so you get them all in the same frame there. There's lots of other stuff that you can do. That's just a taste. So this is an IPython notebook. I guess now it's called a Jupyter notebook, but that's just rebranding. This is the version of Python that's running. You can change that if you want to by changing the kernel. So here we are running Python 2, but if you prefer to run Python 3 or something else, you can. Notice that you can change to these other programming languages, like for example R or Sage or Octave, and that's what I do in these other demo files. So let's look at those. So let's look at the R one. To be honest, I don't know much about R. I took all of these examples from the internet, but this is just hello world. This is creating a pie chart. So the way this first one works, it creates a pie chart file and saves it as a JPEG, and so you can look at it. There it is. But maybe more interestingly, you can do it in a cell like this, and it prints it right on the screen. So here's some other stuff. Here's I guess this is a normal distribution based on some sample data, I suppose, with n equals 1,000 samples and this mean and this standard deviation. And then you can measure those things using these built-in functions, and the values are a little bit weird, so I guess it's based on sample data. Yeah, and there's tons of other stuff you can do. You know, you can do everything that R does, and I know that there are big, thick books on that. By the way, inside these cells, you can do other things besides running code. You can also do stuff in Markdown. So in Markdown in particular, you can use LaTeX, and you can make nice pretty notes for your students. Like, I'll just do something really quick here. So here's an integral of x squared in LaTeX, and here's a header, and here's a hello message, and then there's that, and then let's put something in italics and run it. I think it's kind of slow. Okay, and it gets nicely typeset like this. So you can make lecture notes using this thing. This is something that I've been doing for a while when I have the energy, and also Shweta has been doing this with the Cocalc installation that she's been running. And this is not specific to the kernel, so you can always do this. This is just a property of the notebook. You can make nice notes and exercises for your students. You can leave sort of the details for them to fill in. And let's go on to Octave. So Octave is a MATLAB knockoff. It's just a lot of the MATLAB commands also work in Octave. It's just free instead of being for-profit software. So here's a couple of examples of things you can do. This just says hello world. This prints out, this is Euler's theorem. -1 is what comes out with a little bit of dust, I guess, because of numerical analysis reasons. Here we do a little plot of a sine wave. This is a 3D plot. It looks like a sombrero. You can do a lot of cool stuff with matrices. This probably would be better for, you know, linear algebra maybe than statistics. I don't know. We can talk about which one is the best, or I don't even know if you would want to formalize it. But here we're defining a matrix, a 3x2 matrix, and you can do scalar multiplication. You can do the transpose. You can define another matrix B and take its inverse, multiply B times its inverse. It's very easy to do a lot of fun linear algebra. Sage is a sort of like an umbrella project that incorporates a lot of these other open source mathematical software projects, like basically all of these. Some of these I've never used before: Gap, Haskell, Julia, Octave, Perry, etc., etc., etc. So those have all been put together in kind of an easy to use uniform interface. That's what the Sage people have done. It's the syntax is very close to Python, and it's sort of like Python but with all of these math libraries built in. And there's lots of fun stuff you can do. You can take the moving average of the first 100 numbers with a time lag of 4, and you get these values. You can turn it into one of these time series objects, which has some nice features built in, like you can plot it, you can make candlestick plots. Let me show you some other things that you can do here. So I'm typing vals ts, and then I hit period, and then I hit tab, and I get an exhaustive list of all the things that can be done using the time series object. So in particular, note there are familiar things like mean, minimum, moment, plot, randomize, etc., etc., etc. So let me show you one other thing that's cool. So let's just say I pick scale there, and then I type 1 open paren, and then I hit tab, and I wait for a second, and what comes up is the documentation, and it explains what this command does, scale, and it gives some examples. So this is just the documentation. It makes some attempt at sort of like formally defining what it does, and then it gives a couple of examples. So that one was kind of minimal. Let's look at another one. Probably plot will be a lot longer because with plotting there are tons and tons of options. No, this is also pretty short. Anyway, sorry. Okay, well, did we do them all? I think so. So we talked about R, Sage, Python, and Octave, and they're all in this thing called Cocalc, and that's basically all I wanted to say.